Hello and welcome to 7th lecture in chapter 19 in our comprehensive course on AI, ML and DS. Now here we in last lecture discussed this thing, data distribution and probability distribution, which are collectively called statistical distributions, and we also saw that what is the relationship or what is the connection between data distributions and probability distributions, right? So now actually our next topic in the link was will be actually this, far below this one. We want to discuss various important statistical distributions, yeah, like uniform, exponential, normal, binomial, geometrical, hypergeometrical, and so on. But in between, I have taken quite a lot of extra things. The reason of doing these extra things is that before we do various statistical distribution, which includes both this probability data distribution as well as probability distribution, we have never introduced the concept of probability throughout our course. And in this chapter, with this lecture, we are introducing two important concepts. One concept is the concept of permutations and combinations, and another concept is the concept of probability. Okay, and both are very, very important concepts. So please pay attention. Now, normally, I have myself gone through several data science courses in order to understand the teaching methodologies of various different people. Many of the courses are available on platforms like Coursera or some reputed world universities like maybe Stanford or MIT, etc., Harvard. So I saw one thing, that most of these courses are designed that way, that initially there is a long chapter or maybe 2-3 chapters, and that is named mathematical prerequisites. Okay, and after in that mathematical prerequisites, they teach everything starting from this probability, combination, permutation. Then they also teach, for example, vector multiplication and matrix multiplication. Then the types of various different matrices, and then determinant. Then they also introduce linear algebra, linear equations, and how to solve linear equations. Now, although that is an approach that initially teach every mathematical concept, and then straightway start discussing data science, starting from data science course chapter 1, okay, then chapter 2. And it is assumed that the student, by the time reaches maybe chapter 15 or chapter 18, he remembers whatever was taught in this chapter 1 or even chapters before chapter 1, that is the chapter of mathematical prerequisites. Now, unfortunately, we are at present living in what we call attention economy, and there are so many different things which are vying for our attention. There is social media, and there are movies on Netflix and Amazon Prime Video. Then some of us are doing job, so there is job and job pressures. Targets have to be met and performance has to be taken care of. Then some are having additional responsibility of taking care of family. So attention is divided in so many different directions that the retention period is reducing. So that means it is, I think, unfair to expect from a student that whatever was taught to him in chapter 0 or the prerequisite chapter, he will remember all the concepts perfectly when that concept are actually used in chapter 15 or maybe chapter 17 or chapter 18, like that. So I have decided to take a different approach. As you know, those who have been following from chapter 1, we never introduced any mathematical concepts or mathematical prerequisite chapter. We straightway started with Python programming in from very first chapter. But as and when some mathematical concept was required, so we stopped, paused for some time, we discussed that concept, and then we proceeded with our data science related discussion. So exactly same thing is happening. We want to discuss various statistical distributions and probability distributions, but first you have to understand this concept, permutation, combination, and next concept is probability. So let us take first one, this permutation and combination. What is permutation? Then permutation is the number of ways to arrange n items where order matters. This is very, very important. Order matters. For example, if I want to write my password, so at that time, we know that, suppose I am told that you have to make your password from only 6 letters, A, B, C, D, E. But one person makes password A, B, C, D, E, another person will make password B, C, A, D, E, or whatever. But in short, he jumbles the order of letters. So all those passwords are different. So that means the process of making password from 6 letters or maybe 26 letters, entire alphabet, or maybe a superset of alphabet, including the special characters and everything. So that process is such that in that process, the order in which the letters are picked up from the set of letters, that matters. So in that case, we would like to see that if there are 6 letters and I am asked that make a 3-word password, 3-letter password, a very simple case. So A, B, C, D, E are the 6 letters, and I am asked 3-letter password. So then you have to think about it that way, that from n possible letters, I have to choose R letters, and I want to make how many such possible ways are there, assuming that order matters. Okay, so that means something like this. Then the formula says that the number of possible ways is given by n factorial upon n minus r factorial. So here, if there are 6 letters and I want to make password of 3 letters, so then it will be what? 6 factorial, this exclamation mark like symbol, that is called factorial, divided by 6 minus 3, because from 6 letters pool I want to choose a 3-letter password. So 6 minus 3 factorial. Now then the next question would arise is, what would be the answer of this? Then the numerator, which I am putting in one bracket here, 6 factorial, can be written as 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So factorial is nothing but you have to start from a given number and you have to go on multiplying it with one less number as long as you don't reach 1, or that is the unity that is the for multiplication. Any number multiplied by 1 is also 1 only. Okay, so then that any number multiplied by 1 is also that number only. So unless and until you reach there, then you will say that you have exhausted this limit, because now when I multiply by 1, that number will be same as this. But before that I multiply by 2, then I cannot say that that number is same as this product 6543. Okay, that multiplied by 2, that will be a new number. But now I stop getting a new number, then I have to stop it. Okay, so that is the meaning of the 6 factorial. And similarly in the denominator, what it will be? 6 minus 3 factorial, or that means that is 3 factorial. So I can write it as 3 multiplied by 2 multiplied by 1. Or other way of writing this same thing is, in the numerator I will write 6 multiplied by 5 multiplied by 4 multiplied by 3 factorial, because see, 3 factorial is nothing but 3 multiplied by 2 multiplied by 1, right? So this in the numerator, this 3 factorial is also does nothing but this remaining terms, and divided by that number 6 minus 3 factorial, that I am keeping as it is 3 factorial. Okay, so in that case 3 factorial from the numerator and 3 factorial from the denominator, that will be cancelled, and in that case what you will get is 6 5 is 30, 30 4 is 120. So how many different ways 3 letters can be chosen from a pool of 6 letters when order when order matters? Order matters means A, B, C and D, A, C and A, C, B are different passwords. Okay, and we know that if you take one takes this password, another takes this password, and another takes this password, then we will say that each one has selected a different password. So order matters means even if the 3 letters are same, A, B and C, everyone has selected same 3 letters, but if they have jumbled them up or collected them up in different order, then each of the result would be treated as different. Then how many such results are possible? Then that would be 6 factorial upon 6 minus 3 factorial, or that would be 120 results are possible. So from a pool of 6 letters, if I want to make a 3-letter password, then total there would be 120 possible ways in which I can collect or gather the 3 letters. Okay, now it is 6 and 3 are just an example. In general, if I have a pool of n letters and from which I want to choose r letters or r things, if I have n objects and from which I want to choose r objects, when order matters, then the formula says that it is n factorial upon n minus r factorial. Here n was 6 and r was 3, so this was n 6 factorial upon 6 minus 3 factorial. I hope that is the definition. Just like you cannot ask that 7 multiplied by 5 is equal to 35, then why 7 multiplied by 5 is equal to 35? This is an operator, and we decided that that operator will mean actually 7 plus 7 plus 7 plus 7 plus 7 5 times, or that means that would be 35, right? Similarly, this factorial is just an operator, or this permutation P, that is just an operator, and whenever permutation NR is written this way, then it means this thing. Okay, fine. Now let us see some practical examples of these permutations, and this discussion is going to be very interesting. Okay, so one practical example I have taken is this: arranging books on a shelf where positions matter. That means it is clearly given that which book you keep on which book, that each will be considered as a different arrangement. Okay, now suppose I have 5 books and from which I want to arrange 3 books. Okay, so 3 I can arrange in different manner. First I can select 3 from a pool of 5 in different manner, and then even if many people have selected same 3 books, still they can arrange in different manner, because orders in which they arrange it or positions of the books, they matter here. So 5 is my pool size, and I want to arrange 3. Okay, so n is 5 and r is 3, and I can write permutation 5 3. Now according to this formula, that will be 5 factorial upon 5 minus 3 factorial. Now 5 factorial I can extend like that: 5 multiplied by 4 multiplied by 3 multiplied by 2 factorial, because this denominator will also be 2 factorial. So I will stop at 2 factorial, and 2 factorial will be cancelled. So what will remain? 5 multiplied by 4 multiplied by 3, that much will remain. So 5 4s are 20, 20 multiplied by 3, 60. Okay. So there are 60 different ways in which I can arrange 3 books from a pool of 5 books. Okay. Now where these things are used in business. So if you want to appoint a team leader and a deputy team leader from a group, okay, then suppose you have a very small team, 4 members, but now from them you want to select 2 people and assign them leader and deputy leader. Okay. And again, the position matters here. So that means A is leader and B is deputy leader. That is different than B is leader and A is deputy leader. Okay. That is the meaning. So then how many such possible ways are there of selecting a leader and deputy leader in that case? So that will be 4 2, that is permutations 4 2, and if I write it, then 4 factorial divided by 4 minus 2 factorial, or that will be in the numerator, it will again 4 multiplied by 3 multiplied by 2 factorial, and this is also 4 minus 2 factorial, and therefore that 2 will be cancelled. This is also 2 factorial, so that will be cancelled. So 4 multiplied by 3, that much will remain. So there are 12 different ways in which a team leader and a deputy team leader can be selected just from a small team of 4 members. Now, next time you are in an organization, everybody wants the software engineering lead of their team. Okay, so next time if you don't get selected as a lead by the immediate boss who is deciding, then don't be too sad, or don't imply motive on your boss also that he has done some politics or something, because it is a difficult task. That you can see that just from 4 member team, if you want to appoint leader and deputy leader, there are 12 possible ways in which you can do the selection. Okay. So that is a difficult task. Password generation. Then if you want to create 3-letter password using 5 unique letters, so positions matter. So then 5 permutations 5 comma 3, and the what will be that here only we have calculated. So 5 factorial upon 5 minus 3 factorial, or 5 multiplied by 4 multiplied by 3 multiplied by 2 factorial divided by this in the denominator is also 2 factorial. So in the numerator what will remain is 5 multiplied by 4 multiplied by 3. Okay, or that is 20 multiplied by 3, that is 60. Okay. Now this gives me the number of this gives me the permutations. Okay. Now examples of permutation, and this is the formula for permutation. The most important thing in the permutation which you have to remember is the order matter or position matters. Okay. So P for P, that is easier to remember. So that means that permutation starts with P and position word also starts with P. So where you put the selected elements, their position matters. Now similarly there is another thing called combinations. Now just like permutations are defined this way, that permutation NR is n factorial upon n minus r factorial. Similarly combination NR is defined as n factorial upon n minus r factorial. That much is already there, but in addition to that in the denominator r factorial. For example, combination 6 3, here 6 and 3 are there, then 6 factorial upon 3 factorial into 6 minus 3 factorial, right? Combination 8 and 6, so then 8 factorial upon 6 factorial into 8 minus 6 factorial, because here 8 and here 6 are there, so 8 minus 6, that is 2 factorial. So this is again the definition. So you cannot ask that why this kind of definition. This is the operator. Combination is a kind of operator, and we have decided that whenever you see this kind of symbol in maths, it means this thing. Now when to use combination and when to use permutation, then as I said, when the order becomes important, then you use the permutations. For example, in that password selection, as I said, that you have decided that ABC, BCA and ACB, these are 3 different passwords. So in that case, order of, though the letters are same, A, B and C, but then order of in which letters are combined, that changes the password. So password selection is a process in which order matters. So in that type of thing, we use permutation. Similarly, combination is when to use, then it is the number of ways to select R items from N items where order does not matter. Okay. So I am asked that suppose you have 10 students, and among them you are supposed to choose any 4 students just to form a team. That is all. I am forming a team. I am not forming a leader or deputy leader where position will matter or hierarchy sort of that. There is nothing. All are team members. Okay. So from 10 employees making a team of say 6. That is one example where combinations can be used. So what will be the formula here? Then the formula will be C, big C, comma 10, comma 4. 6, because I want to make a team of 6. Okay. Now what will be the that formula mean? The formula says that n factorial. So here 10 factorial. I am putting there in parentheses. So 10 factorial divided by another also I am putting in parentheses n minus r factorial. I am writing this part. So 10 minus 6 factorial. So that is 4 factorial, correct, and into r factorial. So r factorial will be here. This is my n and this is my r. So then r factorial will be 6 factorial. Are you understanding? Okay. So in that case, this is r factorial, that is this, and this is n minus r factorial, 10 minus 6 factorial, that is the other right side term in the denominator. Okay. Now if I find that, then what I will do for numerator, 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5, 4, 3, 2, 1. Okay, but that is 6 factorial. So I am writing it 6 factorial only because that will be cancelled with the 6 factorial in the denominator. So 6 factorial and again multiplied by 4 factorial. So that is 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, so this is 4 factorial. Okay, I hope that things are clear. So in this case, what will be the answer? So then this 6 factorial and 6 factorial will be cancelled. So in that case, what will remain in the numerator? So if I find what will remain in the numerator is 10 multiplied by 9 multiplied by 8 multiplied by 7. Okay, and what will remain in the denominator is 4, 3, 2. Among them also 4 to the 8. Okay, so 4 to the 8 and this 8 will be cancelled. So what will remain in the numerator? 10 multiplied by 9 multiplied by 8 has been cancelled with the 8, that is 4 to the 8 in the denominator. So 8 has been cancelled, multiplied by 7. 6 factorial has been cancelled with 6 factorial in the denominator, correct? So only this much will remain. And of course in the denominator, still something will remain. 4 to the 8 has been cancelled with this 8. So 10, 9 and 7 have remained. 6 factorial is also cancelled with this 6 factorial. But in the denominator, 3 has remained. Now that 3 also can be, 9 can be divided by 3. So that means here I can write 3 3s are 9. So I can put this as 3 and remove this. So how many combinations are possible? Then 10 multiplied by 3 multiplied by 7, or 7 3s are 21 and multiplied by 10, so 210. Okay, so how many combinations are there to select 6 employees in the team from 10 employees? Okay, so then there are 210 combinations. Now think, look at this, how difficult it is to get selected in Indian cricket team. Okay, because there are 16 members including the substitutes. Okay, if you want to be in playing 11, then there are only 11 members. So if you want to be in those 11 members, okay, and if you are, and there are maybe how many people of your age group, or that is that team selection age group, maybe I think team selection age group, let us take 16 years to 26 years period, okay, beyond which there is not much chance. Sachin Tendulkar played at slightly higher than 16 years, and older players who are lucky, they get selected at 26 years. So in this 16 to 26 years, assuming that there are maybe how many citizens are there in India, so I just take a conservative approach that 2 crore people. Okay, so 2 crore means 2, then 100, 1000, 10,000, then lakh, then 20 lakh and 2 crore. These many. So from these many, you have to come in the 11. So that means here what will be the formula? C into 2 crore, comma C into 9. Sorry, C 2 crore, comma 11. Okay, and that will be the chances. That many combinations are possible. Now among them, there is only one combination in which you are, there are only limited combinations in which you are present. So now you understand how difficult it is for anyone, any youngster who aspire to become a cricketer in Indian cricket team. He has to come in one of millions or millions and millions of possible teams which are selected, 11 members from a population of 2 crore. Okay, that is the reason why cricketers are so highly paid, because they have to be exceptionally talented. So otherwise they will not stand the chance to get selected in the last 11 from so many combinations. Okay, so we should, whenever we feel jealous about any profession, we should always think about the probability or chances, that what are the possible ways in which these things can occur, and if it has occurred for one particular player, then what odds he has overcome to get selected in the team. Now think, get selected in the team is just first thing. Many of the people hardly play maybe 50 test match, then or 51 days or 50 T20s. Then being the greatest in that, like a Sachin Tendulkar maybe, or maybe Anil Kumble for wicket taking, how small will be the odds for that? Highest run getter, highest century getter, or highest wicket taker from entire all the teams who have played for India. Okay, so the person who has defied all those odds, he becomes that record holder, and that is why they are treated as the greatest icons in the game. Not only for cricket, but this is true for every other profession, right? So very few people defy all these odds and make it to the top. Okay, now coming back to our discussion, let us take some more easier examples, because these would make things a little bit sad in some states. Some people may become sad that my chances of becoming CEO of a company are so less. Yes, they are less. You have to put a lot of efforts, some luck, and a lot of skill and intelligence has to be with you. Okay, now you have six type of fruits and want to pick three to make a fruit salad. Now remember here why order does not matter, that you should understand that which three fruits you pick up, that does matter. Okay, so that means then each salad will be different. But once three fruits are decided, for example, apple is decided. Next is say orange. Orange is not put much in fruit salad, but okay, let us take it. And next is say banana, and these three fruits. Now, one person has. There are multiple people who have chosen these three fruits. Then one person puts apple first in the custard, then he throws orange, and then he throws banana. Another person says, no, I want to throw banana first, then orange, then apple. Another person says, no, I want to put apple, orange first, then apple, and then banana, like that. So that order does not matter because everybody will make exactly same kind of fruit salad. Okay, so that is just combination has to be calculated, not the permutations. So combination 6, 3. So that will be 6 factorial upon 3 factorial into 6 minus 3 factorial. Now, if you count that, then that would be 20. Okay. Then out of 10 players, 4 are to be selected for a match. That is just like that team example. Okay. So 210 are the possible combinations. Now, this is again showing how the job of selectors is very difficult. Okay. Because in every cricket team selection, around 7 players who are already giving consistent performance, they are already selected. They have been playing for India for maybe last 5 years, and they have excellent average as a batter or as excellent bowling record or excellent catching record as a wicket keeper and stumping and etc. In short, they have impressive statistics. So 7 spots are already taken by them. Now 4 spots are remaining, and for which you have suppose around 10 candidates. Then how many different ways you can select 4 candidates out of a pool of 10? Then 210 ways. Okay, so that is 210 different combinations can be made. Now a lottery selecting 5 numbers from a pool of 50. So that has 50 combination 5, and you can see that how many possible combinations are there. Then there are this many, and most of the actual lotteries, which are big lotteries, this is actually some street or small club lottery. Okay, but actual big lotteries or jackpots, they require you to select 10 numbers out of maybe 100 different numbers or 10 out of 1000. So you can understand that what will be the possible combinations, and among them only one will win. Okay, so randomly selected one person will win. So that is the reason why it is said that lottery is not an ideal way of making a career. Okay, so one should not depend on lotteries for earning. Okay, then permutation and combination, these are foundational in machine learning, and they are particularly useful in scenarios which are involving counting possibilities, feature engineering, and probability. So the reason of taking that permutation combination lecture is that slowly you should get the idea of the odds. So from all the discussion, you get the idea of the odds or idea of the chances, probability, those things. Okay. Now in our daily life, we use all these as the same words, but actually they have different meaning, and the scientific definition of probability also we will take. But first, we will use some applications in the data science where these permutation combinations are useful. But that would be in the next lecture. See you in that. Thank you.